Now I'm going to do a problem which the life of the alternatives are limited, but we want to keep them forever. So to explain, you have two alternatives, A and B here, and we want to see which one is better using the capitalized cost approach. We don't want to use present worth method. We don't want to use annual cost. We're going to use capitalized cost. So I'm going to start with alternative A, which is I'm going to show the cash flow diagram. By the way, this is problem 6.3 here. So the cash flow diagram for alternative A, we do have to do only for one cycle. We don't need for multiple cycle. So this is initial cost is 31,000. The annual operating cost is this is year 1 through year 4. So the life of this alternative is only 4 years. So the annual operating cost is 18,000. So that's uniform payment from year 1 through year 4. Then you have the salvage value of 5,000 at the end of year 4. Now, we want to compare these alternatives using the capitalized cost method. If you recall from previous example, the capitalized cost for alternative A is going to be basically the annual cost or EUAC for alternative A over interest rates, because we are using the equation P equal to A over I. So what you're trying to do here is we are trying to repeat this equipment every 4 years forever. Then it's going to make it uniform. So if I do this on the EUAC for A over I, I'm using that equation. Then I can find the capitalized cost for A. So the first step here is to find the annual cost for alternative A here. So that's what I'm going to do first. The EUAC for A is going to be this. So we're going to convert, everything is not uniform. 31,000 is not uniform, we're going to make it uniform. So negative 31,000, because the present value, we're going to multiply by A given P. Oh, and the interest rate for this example is 15% per year. So 15%, and the life of this one is 4 years. So that's going to make this 31,000 uniform. Now the 18,000 is uniform, then you don't have to do anything. 18,000 negative. And the last one is the salvage value. That's positive. That's the future value. That's why you're going to multiply by A given F and 15% and 4 period. That's going to give the annual cost or EUAC for alternative A here. So this is EUAC for alternative A. If you substitute, if you get A given P and A given F from the table and substitute, you're going to get the number. It's going to be negative $27,857.02. So this is annual cost. We don't need annual cost. We need the capitalized cost. To find the capitalized cost, we're going to divide the annual cost over the interest rate. This is going to be negative $27,857.02 divided by 15%. That's going to give you the capitalized cost for this example. It's going to be a negative $185,713. So this is the capitalized cost for alternative A. So what does mean here is this. If I have $185,713, I can repeat this equipment every 4 years forever. So that's why we call the capitalized cost associated with this alternative. Now, in previous part, we find the capitalized cost associated with A here. Now we're going to do for B here. In order to do this, we're going to find the cash flow diagram only for one cycle for alternative B here. So alternative B, the initial cost is 43,000. That's times 0. Then you have annual operating cost 19,000. So this is, and the life of this alternative is 6 years. 1, 2, 3, 4, 5, 6. So 19,000 uniform payment for annual costs. And the salvage value for this one is 7,000. That's positive. So this is, again, when you do capitalized cost, you don't have to do multiple cycles. You just do one cycle and then repeat this one forever. So in order to find the capitalized costs associated with alternative B, first you have to find the annual cost for alternative B divided by the interest rate. Then you're going to be able to find the capitalized costs. So first, I'm going to find the annual costs for alternative B. We call this one EUAC for B. So when you do annual costs, you convert everything to uniform payment. Anything is not uniform, you have to make it uniform. You have 43,000 at time 0, that's not uniform. You have to make it uniform. So because it's a present worth value, you're going to multiply this one by A given P. And the interest rate was 15%. And the number of period is 6 years. So that's going to make this payment uniform payment. The $19,000 uniform, you don't touch it. Anything is uniform, leave it uniform. Then the last one is the salvage value, 7,000. So 7,000 positive, that's income. Because the future value, you're going to multiply this one by A given F and 15% and 6 period. So that's going to give you the annual costs associated with alternative B here. You have to go to table, find A given P, A given F. After substitution, you're going to get the EUAC for B here. For B is going to be 29,562.64. So that's the annual cost for alternative B here. In order to find the capitalized cost for this, you just divide the annual cost over the interest rate. So it's going to be negative $29,562.64 divided by 15%. And if you find this, it's going to be negative $197,084. Now, if you recall, for the first part of the problem, the capitalized cost for alternative A was $185,713. And if you compare this, obviously the A is lower than B here. So we can say this. The capitalized cost for alternative A is less than capitalized cost for alternative B here. Therefore, you select alternative A. So what does it mean is this. If I want to have equipment A, it's going to cost me $175,713 at the present time. So I can repeat alternative A forever. And for alternative B, it's going to cost me a little more, $197,000. So obviously this is lower. We're going to select alternative A.